So welcome to the first of our weekly Zoom meetings for MAT267 Summer A Session 2026. This is basically just like having office hours. Um, you can ask me questions from the Edfinity and I can go over them with you. I have a camera here that'll do that. And I am recording this, so it'll be available afterwards. You can view it later. Um, you don't have to ask questions. You can just kind of watch. Um, However, I generally go by what questions you have. So if you have a burning question, I'd be happy to work one out with you guys. So anybody want to be the brave one and get us started?
Um, for
Yeah.
number 10.3, or for section 10.3, number 15, I was just wondering if there is a faster way to kind of recognize those as we're looking at them.
All right, let me go to it. So you said 10-3, number 15.
Yeah, like C and D have a lot of answers. And so I didn't know if like we were supposed to draw them before,
All
like
right.
what's the best way to go about that problem?
Well, I'm going to share the screen here. So we have five vectors. This is 10-3, number 15.
Yeah.
And we want to see which ones are perpendicular, so on and so forth, parallel. They're going to be parallel if they are multiples of one another.
Yeah, if there's a scalar, right? So
Yeah,
that part, and then it was kind of easy to recognize the ones that were perpendicular, and then the obtuse ones are what was the other question? It was yeah, and then whether they were obtuse or acute, I kind of just had to put them all in because
Oh,
but I did.
you just take their dot product.
Okay, so the dot.
So for part A, they'll be perpendicular or orthogonal if their dot product is zero.
Yeah, just with all the combinations, I didn't know if there was a faster way to kind of recognize that. I got the answer
No.
right by doing it that. Okay, so it's really just putting every single
Well,
combination.
you're only going to be taking, what do you have here? You have five, choose two, so 20. You're going to be taking 10 actual dot products,
Yeah.
and those will go quick.
Yeah.
So you're looking for, if there's zero, they are orthogonal. If they are positive quantity, they are acute. So the
And
angle would be
negative.
less than pi halves. And then if it's a negative quantity, it would be obtuse. So that would be part D. And as far as parallel is concerned, the dot product does not tell you anything if they're parallel. You just have to look at to see if one is a scalar multiple of the other. So when I'm looking at these, it looks like A and B are.
A and D.
B,
Oh, okay. Yeah, mine didn't have any because of the fact that the it swapped up the negative and positive signs. So I had one that was a scalar, but it didn't. The
right?
signs didn't match. So I ended up with a none on that one.
Yeah. Yeah, your problems will vary a little bit.
Yeah.
The coefficients are randomly chosen. Um,
Yeah.
if I were to
You're
do like A dot C, for example, it'd be 5 plus 5, take away 1 is 9. The A and C are acute.
yeah. Okay, that's how I did it. I just didn't know if there was like a trick.
That's the trick.
Okay.
That is the trick.
Yeah.
All right. Does that help you?
Yes.
All right.
And then I'm looking for some of the, if somebody else has one, they can definitely jump in. I'm looking for some of the work product ones that were confusing, but I'll look through Edfinity and I'll find them and then I'll let you know.
Okay. Yeah. Anybody else want to jump in and ask a question? Basically, we're working on the first few modules of mod 10. So 10.1 through 10.4. Could go over 10-2, number 11. Let's take a look at that one. So let me go to it. Give me a second. I'm going to share the screen. A horizontal clothesline is tied between two poles 10 meters apart. And when a mass of 3 kilograms is tied to the middle of the clothesline, it sags a distance of 5 meters. What is the magnitude of the tension on the ends of the clothesline? All right, I'm going to draw the picture. So this is 10-2, number 11. Give me a moment to copy the information down. So the mass is 3 kilograms. We have 10 meters between the poles, and we
I
assume
think
the
it
mass is in the center.
I,
So,
I think it does say that it does say in the middle of the clothesline.
all right, that's important. So it's going to be sagging 5 meters. All right. So I've got the information here. I'm going to stop the share. Um, Give me a moment here. I'm messing myself up here. I want to change my camera. There we go. And then let me pin this. All right. So we're playing with vectors here. First of all, we need to actually get the weight. So the weight is mass times gravity. So 3 times 9.8. What does that give us? 29.6 or 4? That would be newtons. I did that in my head, so
Yeah, 27, 2.4, 29.4.
come on, yeah, okay. All right. So yeah, basically you have a whole bunch of vectors. You have a tension value here, which I'll use magnitudes here, mag t and mag t. And basically I'm going to decompose these into some sets of vectors here. I'm going to have a vector going this way and this way. This vector here will be mag t. Here, I'll put a little angle in here, theta. This will be mag t um, sine theta because it's opposite. This will be mag t cos theta. You're going to get the exact same thing. You're going to get the exact same thing on the other side. You're going to get competing vectors. This will be mag t cos theta. This will be mag t sine theta. And here's the deal. You'll notice that the two horizontal vectors cancel. So I could write it. It would be mag t cos theta minus mag t cos theta equals 0. So they're gone. We don't really need to worry about them. The two up vectors here, these two guys here have to counteract the downward force here. So I have 2 mag t sine theta equals 29.4. And that's in newtons. Okay. Interrupt me if you have any questions. Does that make sense what I'm doing there?
So because it was in the center and one's positive and one's negative, that's why those would cancel each other out for the
Yeah, we have symmetry here.
okay.
If it wasn't in the center, we would actually have to perform a system. It can still be solved, but it would be a system in two variables because the tensions on each of the lengths would not be the same.
Okay.
All right, I'll just go ahead and solve for mag t, and that's going to be 29.4 over 2 sine theta. And here's the deal. I don't really need to worry about what the angle is because I actually have enough information here to figure out sine theta. if theta is right here, um, it's just simply going to, well, in this case, it's going to be 5 and 5. Well, let's see what we've got going on here. It's going to be, these can be split in half, so we have fives there. The sine of an angle is going to be opposite over hypotenuse, right? And
Yeah.
so it's the opposite would be 5. And the hypotenuse, well, it's going to be 5 squared plus 5 squared, square root of that. So it's going to be 5 rad 2. So we get this thing, it's 29.4 over 2 times 5 over 5 rad 2. Those cancel. Actually, the 5s cancel as 2. So it looks like you just get 29.4 again. It seemed too easy, but I think that's correct.
The 2 canceling with the square root 2, wouldn't that be like
Oh
2
yeah,
divided
yeah.
by the square root of 2 would be the square root of 2, right?
You are correct. It did seem too easy, didn't it? Yeah. So 2 over rad 2, actually 2 over rad 2 is just rad 2. Let's stretch that
Yeah.
out. It was 29.4 over rad 2. And I'll get my calculator off of that. 9.4 divided by rad 2. 20.79. And that would be newtons.
For Edfinity, we can leave it in the radical form though, right?
Sure.
Okay.
You can always try it. If not, try a simplified form. Don't don't um don't round your answers too early though. Give it like 4 or 5 decimal places if you're going to do that.
Yes.
All right. Um, okay. Very good. Very good. Any is that okay? So any questions on this one? This was 10-2, number 11. And notice that you don't have to worry about the angle. You just need to figure out that basically you have enough information here to construct the sine of the angle because you have the information about the legs and the hypotenuse. So you don't need to worry about arc sines or anything like that.
Um,
So I'm going to share the screen.
so far
10
all the Yeah, so far all the examples I got were like fairly straightforward. They were up or down. I haven't gotten any that were like northwest. I don't know if we just haven't encountered those yet or if I just haven't done enough problems.
Um, well, I can draw it if
Okay.
you have mag u. Doesn't really matter what the magnitude is. We just need to know it points north. So we have u pointing north. That would be straight up if you're looking at a map. And we
Can you
have,
switch can you switch your camera?
yeah. Let me get this copied down
Oh,
because
okay, no
I'm gonna have to
problem.
remember. And then v points northeast, so it's gonna be this way. All right. So let me switch the camera. Let me stop the share. That's blurry. All right. And so the question was the cross product u cross v. So we're specifically going u cross v. And so I'm going to bring in my hand here.
Okay.
I need to actually curl my fingers on my right hand. Sorry about that. From U to V. And to do that, I have to actually turn my hand over. So my thumb is actually pointing down. U cross V would be pointing into the paper. V cross U, on the other hand, you can see that I'm going from V to U. My thumb is pointing straight at you, points upward from the paper. Okay.
So do do with using that rule, do they always kind of go up or down, or are we going to be dealing with tilted ones that would go like southeast or northwest or
Well, you're going here, you have two vectors that lie in the plane. So
yeah.
north and northeast and south and all that makes sense. But when you go into the third dimension, suddenly the north and the northeast and all that business don't make any sense
Okay.
because the cross product is actually taking two vectors. The cross product exists in R3. You can do it with two vectors in R2 as long as you just have a zero in the third component. The cross product vector will stick out of the plane. So it's either going to go up like this or it's going to go down. So it's going into the third dimension. So really the purpose of this question is to help you get a sort of a visual sense of how the cross product behaves. Okay. Um, I was looking at the question here. It says, please enter the letter of the correct answer. That should be D for down.
Mm-hmm.
And then the magnitude, since we'll go ahead and do that, mag u, a mag of the cross product is going to be mag u times mag v times sine theta. We were told that u was 10, v was 1, and sine of theta, this would be 45 degrees, or pi over 4. So because northeast is 45 degrees off of north. That's going to be root 2 over 2. So 5 rad 2. Makes sense. Let me label this. This was 10-4 number 3. Should put that down. There you go.
Okay.
Again, anybody else, if you want to jump in, feel free to jump in.
So, um, so my question, so it kind of, when we're dealing with the cross product and they're on one plane, then generally each time that we're doing it, it would be up or down. The
Well,
southeast and southwest wouldn't really come into play, or they'll come into play
no,
in
the
other.
cardinal directions as we know them on a map only exist in R2.
Okay.
It's only here for convenience. One
Okay.
way to think about the cross product is that any two vectors in R3 can be placed in a common plane. The plane might be tilted, but the vectors will be in a common plane. The cross product will actually be orthogonal to that plane.
Okay.
So the cross product always creates a vector that's orthogonal to the two that you use to create it.
Cross product is orthogonal.
In this example, your two vectors are actually in R2, where the z value is 0. So the cross product will actually stick up or down. But again, the notions of up, down, left, right, north, south, they become a little vague when we get into R3. So we have to be a little careful with using that kind of terminology.
Okay. Yeah. I ordered some isometric graph paper because I think it's hard for me to visualize them in 3D. And when I'm drawing them and trying to get the points in Z, I don't think I'm accurate when I'm drawing them or it's confusing me. So hopefully the isometric graph paper will help.
Yeah, yeah. Also, I guess it depends on what you're doing, but some of Desmos can do some of these things pretty nice, especially
I
when you start graphing in 3D and you
I
know,
have I have been playing with the Desmos 3D calculator, and you said that we will have that available
yeah,
on the test, right? Because
I'll give you all the
that
Desmos.
that is really helpful.
Yeah,
I
it is
started that
nice.
yesterday. Before I was trying to do it all on paper, and I guess I'm not a very good three-dimensional drawer without like the I'm gonna try it with the orthogonal or with the isometric graph paper.
It takes practice.
Yeah.
There's no doubt about that. The better that you can see the third dimension, the better, frankly, the easier this stuff will be.
Yes.
Um, you don't want to be totally reliant on just the formulas. You need to be able to see what's going on, but that takes practice.
That's what I've been like. I'm getting the numbers right. It's just a little bit harder for me to visualize. And normally I can visualize the graphs really easily in two dimensions. And so,
Mhm.
like you said, it's just practice. I'm gonna, because I like to draw whatever I have on Desmos as well so that I can understand it and get that um like muscle memory of it as well. So I'm hoping that that helps me to kind of get the drawing them myself down a little bit better.
Yeah, yeah, by all means, take
Yes.
advantage of those tools.
Yeah.
So I noticed on the calculators section of the modules, it does say the Desmos 3D version is not allowed on tests.
I decide what's on the test.
Okay.
So I'm going to go ahead and give you it all.
Okay,
What you're,
perfect.
what you're seeing in you saw that probably on Canvas, right?
Yeah, it's on the modules on Canvas under
It's,
calculators.
it's a, that's the standard Math 267 Canvas page. And I don't go through every last nook and cranny and correct things. So
Okay,
some of the
perfect.
stuff seems to be overly strict or contradictory to what I say. Um, I, I, I put down in I think it was an announcement. I forget where I did it, but it may have been on Ed discussions. But I basically said I'm giving you all the Desmos.
Oh, okay, wonderful.
So if you see something in Canvas that sounds worrisome, just let me know.
Okay, sounds good.
Sure. So 10.5.21.
Yes.
All right. Consider the planes 5x plus y plus 3z equals 1 and 5x plus 3z equals 0. Find the unique point P on the y-axis, which is on both planes. Find the unit vector u with positive first coordinate that is parallel to both planes. All right. And use parts A and B to find a vector equation for the line of intersection of the two planes. All right. Let me copy the information down. This is 10.5, number 21. I'll change my camera here in a moment. I just got to copy it down. 3z is 1. 5x plus 3z is 0. Um, well, we can probably verbally answer the first question just by common sense. If you're on the y-axis, what are your x and z values?
If you're on the y-axis, your x and z values are 0.
Right. So just set x and z as 0, and the second equation just drops out. The first one would just give you y equals 1.
Yeah, and then you end up with 1/5. And then you can plug that into the second equation to get your z value.
Where did you get 1/5 from?
I did. So if I had, oh no, it's 1/1. Mine was 1/5. So if z
Uh,
and so then it's 1. So then you would plug 1 into the second equation, right? 5x
do we
plus.
want to find a unit vector with positive first coordinate that is parallel to both planes? All right. Okay, this is exactly where the cross product becomes handy. Okay, because from the first plane, I'm going to temporarily unshare. From the first plane, we've got a normal vector 5, 1, 3, and from the second plane, we'll call it n1. From the second plane, we've got a normal vector 5, 0, 3. Okay. Um, these two vectors stick out of the planes orthogonal to their respective planes. That means that a vector that's orthogonal to both of these vectors will actually be parallel to the plane. Does that make sense? It's kind of like orthogonal to orthogonal. So these are both orthogonal. This is orthogonal to this plane. This is orthogonal to this plane. The cross product of these two guys will create a vector orthogonal to both of these guys, therefore parallel to the where these two planes intersect. You know what? I can draw a picture. Call this one P1 and P2 for plane 1 and plane 2. You have these are coming out at 90 degrees, so this would be N1 and this would be N2. Now, if I scoot these guys together, I can always put them together. I can always move their feet around. This would be N1 again. This would be N2. Their cross product is actually going to be doing that.
Okay.
So that's what we want. So we got to figure out the cross product of this guy. I'll do the formula real quick. It's N1 cross N2. I usually do it using the 3x3 determinant. Let's see, we got for I, we have 3. For J, we should have 0. Yeah, we do. And for K, we're going to have -5. And I got to check that. I got to make sure that when I dot it with the original vectors, I get 0. So 3, 5, 15, 0, -15, that works. That's going to be 15, -15, 0, 0. It works. So this is the cross product. So this is actually the vector that is parallel. I forget what the question was now. This is the vector that is parallel to both planes, and it wants a positive first coordinate. All right, well, I've got that. Okay. And then use parts A and B to find a vector equation for the line of intersection of the two planes. Well, we know that the pass-through point from the first part was 0, 1, 0. So I can just kind of take these two guys together, and my line will be, well, I'll write it as vectors 0, 1, 0 plus t of 3, 0, -5. And depending on how it wants it entered, you can type it in. For example, it would be, let's see, 0 and 3t, 1, and then 0, -5t. And that would be the line. That would be the vector equation of the line where the two planes intersect.
Mine said find the vector unit U with the positive first coordinate that is parallel to both planes, and then use parts A and B to find the vector equation for it.
Oh, it wants a unit vector.
Yeah.
All right.
Because
I
I've
didn't
got
do
square
that.
roots in there. Like, hold on.
So what would that be? I don't know why it wants a unit vector. You don't need a unit vector for this. That would be 25, so we're at 34. So
Yeah.
looks like it's just going to be rad 34s. Now on this one, it's just going to drop out. So
Okay. Yeah, I kept missing that part. Okay. Unit vector coordinate. And it's us figuring out which vectors are equivalent, and then the like
okay. This one.
Yes.
All right. I'm going to click on the thing to enlarge it. You can't see that, can you?
Let me look at the Zoom.
Can you? Okay, because can you see this screen right now?
I can see the screen of Edfinity.
Okay, but it says like you see the box here toward the bottom, and you see the questions to the left. Okay. All right, good. So let's just kind of look at these here. You're gonna have to refer to this picture down here. Now, if I click on the picture, you won't be able to see that. So I'm going to keep the picture the way it is.
Okay.
And this is another three-dimensional situation. Here's the origin. Can you see my little pointer there?
Yes.
Okay, there's the origin. Here's the x-axis coming this way to your left. Y-axis is coming kind of to your right, and the z-axis is going up. But you have to visualize this in three dimensions. So you
Mhm.
have to visualize that this is a box, and you have vectors along the edges. You have this vector down here, which I can't even see that letter. I think it's E. That's like a
Mhm.
diagonal from the origin out to here. And then you have this vector, which is G, which is a diagonal from the origin up to this, I guess you could say the upper left corner. So the question is vector G the sum of F and A? Well, let's see. I put my F is over here, but I can move F over here. So I can rigidly move F so that its foot is at the origin. And so if I have a vector from starts at the origin, goes up to this point up here, that's F. And then A picks up and goes out here. So yes, G is the sum of F and A.
Okay.
Now, is A the opposite of B? Uh, no, because A and B are actually the opposite of A would have to be something parallel to A but pointing the other way. So basically, you take the A vector, put the arrow on the other
Okay.
end.
Okay, so the arrows, the way that the arrows are going is I think what threw me. So if say that B was like J, then it would be opposite, correct? Because the arrows would be going different ways.
No, J is actually in a different plane entirely. So B is up
Okay,
here.
so okay.
Yeah. So like, I don't think we have one. Like A and B, for example, are parallel but opposite.
Okay.
So A equals negative D and vice versa.
Okay.
Um, C is C equal to F. Well, here's C over here, and here's F. They are pointing in the same direction. Yes, they're the same vector because they're basically, you have a rectangular box here. So these things can be rigidly moved. Is A equal to D? No, but strictly speaking, no, they're not equal, but they are parallel. A and D are opposites.
Okay.
D is G minus C. That's the same thing as asking is D plus C equal to G. So is D plus C equal to G? And no, because for that to work, D would have to actually start at the origin, come out to C, and then that would work. So D plus C is not G, so 5 is false.
Okay.
And then same with E. I find it easier to do addition, so I'm going to bring the B over. So E plus B is A. Here's E and B. No, it's not even. Well, actually, you know what? It is. Actually, it does work. Check this out. If you bring the B vector down to here, the E vector comes out, and then the B vector picks up and goes to here. So yes, their resultant would be this little bit would be A.
So
So this is
could
true.
we have done like I know J's not on there, but could we have done the same thing with J if we moved it up to the top of the box and then it
Yeah,
would be
you can move
equivalent to
vectors.
A?
You can move
Okay.
vectors can be moved at will.
And then so if I moved it up to where A is and A is going one direction and A's and J's going a different direction, would those be equal because they're going like the vector of A equals negative? Would it be the negative J if I was to
A
move it?
is Yeah, A would be equal to negative J. Actually,
Okay.
notice that D and J are actually the same vector.
Okay.
C and F are actually the same vector.
Okay. So I
Okay.
think I wasn't paying attention to the arrows is what happened while I was doing when I was trying it. I was like, yeah, those two are equal. And then I wasn't paying attention to the direction that the arrows were pointing.
Yeah, the arrows are important.
Okay.
Um, you had mentioned a couple other questions along
Oh,
these
we
lines.
did 11. So it was 13 and then it was 10 and 12 both deal with like that's the child walking due east on the deck was 10 and
Yeah,
then the ship's going a certain miles per hour and So I just had trouble like setting. I ended up going to the get help, seeing how they did it, and then like plugging my values in. But looking at those, it was just hard for me to figure out what I'm drawing and which direction everything's going in.
That one would just be a right triangle.
Okay.
Um, let me draw it real quick. I'll switch my screen. You have a vector going north at 1, and
Okay.
you have a child walking east at 5. Um, and we want the speed and the angle of the direction from the north. So what I would do is I would actually do it like this. I do it like that, and then the kid is actually moving in that direction. If you look at it, from above, and so the speed is going to be the magnitude of the hypotenuse. So it would be rad 26. The angle here, they want it from north. We'll figure it out. In this case, yeah, you have to figure it out. This is going to be arctan of 1/5. So this angle here would be 90 minus, or actually pi over 2. I should keep this in radians, minus arctan 1/5. Because I'm taking the complement. And that's really all you do on that one.
I'm sorry. It's a something pi over 2 minus arctan of 1/5. What does it say before the pi over 2?
That's a scribble.
Oh, okay.
I
So
had
pi over.
written 90. Make sure
Okay.
you're in radian mode.
Okay.
Arctan is radians by default. So
Yeah.
you have to always be in radian. And then number 12, um, this was obviously inspired by Lord of the Rings, I'm guessing. The 9 ring wraiths want to fly from Barad Dur to Rivendell. Rivendell is directly north of Barad Dur. Dark Tower reports that the wind is coming from the west at 70 miles per hour. In order to travel in a straight line, the ring wraiths have to head northwest. At which speed should they fly? Um, well, they have to fly into the wind. It doesn't tell us how far north. I mean, we're going to assume that they're going to fly at northwest. I'm reading the question again. Yeah, okay, northwest. All right, so basically, we have a situation here. I'll unshare where you've got this wind vector at 70, and so we have to kind of travel into the wind at northwest, and that means that we will so this will be what they do. So this is the direction they have to fly. We'll call it U. So that this will be U plus W. So this is the starting point and the ending point. We want to start and end due north of the starting point. So we have to kind of fly into the wind because we know the wind is going to push us back. All right. So if this is coming at 70, it seems like it's lacking a bit of information here. If well, okay, it's just going to be 70 rad 2. So because this would be a 45-degree triangle, so 70 rad 2 miles per hour. Okay. That should be whether they're flying for 1 hour or 3 hours, or I don't think it matters.
Okay. So they're a 45-degree angle. That one. That one. Northeast. We know that that would be like a compass rose and it's at 45 degrees.
Right.
Okay.
Now, it is important. I have had students not know this. So
Okay.
here are the cardinal directions. And then at 45 degrees, you have I guess, your secondary directions.
And if they don't give us like we're heading for 36 degrees east or something. Like
Right.
if they're not giving it to us, we're assuming that they're heading straight in the middle because northeast would be
Yeah.
45. Okay.
Yeah, so northeast would have to be, northwest doesn't matter. It would have to be 45 degrees.
Yeah.
Otherwise, you don't have enough information to solve the question.
Okay. That makes sense. I think that was all of the questions that I had. If anybody else had anything from the homework or any questions, you guys are welcome to
Well-
jump in. We got a couple more minutes. No? Okay.
We're
I
good?
think I'm good for now.
All right.